Hello and welcome everyone. How are you all? So, I am Siddharth Kumar Jha, and in machine learning today I am going to talk about model evaluation in regression. Okay? So, just do a recap like what we have did till now in the regression part in machine learning. So, we have did the multiple linear regression which used to predict using the multiple features, and we have also see about the polynomial regression, so it fit nonlinear trends, and we also learned about bias variance trade-off, understanding versus overfitting. Sorry, underfitting versus overfitting. So tell me like why evolution is important, okay? So till now we have like built our model and so on. So like why model evolution is important, okay? So this is the main motto of the today's video. So let me go to the notepad for its better understanding, model evaluation. So just wait a second. I am going to open my notepad. Okay. So let me write down why evaluation is important. Okay. Like why evaluation is important. So it is important because like when we are building a model is not enough, we must check how good it is. Okay. And the different metrics helps to understand the error and the accuracy. Like whether yesterday we have talked about the precision, recall, accuracy, F1 score, all that. Okay. So that all helps to analyze the model accuracy. So that's why the model evaluation is important, like how good our model is working. Okay, and how good it is predicting the outcomes. Okay, so let me write it down. Building a model is not enough, is not enough. We must check how good it is, how good it is. Okay, so what happened? Like for evaluating our models, to different metrics is there to help us to understand the error and accuracy of our model, so that we can evaluate our model. Okay, so that's why the evaluation is necessary in the machine learning. So next, the topic is like regression evaluation metrics. Okay, so next is regression evaluation matrix. Okay, so what it is basically? So the first one in this comes like mean absolute error. Okay, so mean absolute error, which is also called at like MAE. Okay, so the formula of finding the MAE is like 1 by n summation of y of I minus y cap of I. Okay, so it is easy to understand and less sensitive to outliers. Okay, so this is like easy to understand, easy to understand and less sensitive to outliers. Okay, so I hope I am clear with the MAE. So the next one is your root mean squared error. Okay, So the second one is your second one. This is your first one. This is your first one. Okay. So second one is your RMSE, which is root mean squared error. RMSE. Okay. So basically the formula of finding the RMSE is root under 1 by n and summation of your y of I minus y cap of I का whole square. Okay. So it is basically like preferred when a big error are costly. Okay. So like there is an error and that error has like more cost. Okay. So that in that case we are using it. So it is preferred when big error are costly. Okay. So I hope I am clear with the RMSC. So the next one, which is your R square score. Okay. So third one is your R square score. So this is nothing but your coefficient of determination. Okay. Coefficient of determination. Okay. So what it is? It is preferred like when the range is like 0 to 1 and closer to 1 means better and means 0 is worst case and 1 is your good case. Okay, so its value lies between 0 to 1 and the formula is like r square is equal to 1 minus summation of y minus y cap yi minus y cap of y ka square divided by summation of y of I minus y bar का square. Okay, so this is the formula for finding the coefficient of determination. Okay, so it value or it range is like a range is like 0 to 1 and closer to 1 which means like equal to better better performance of our model. Okay. So next one is like adjusted R square. Okay. So next one is your adjusted R square. So what it is? So adjusted R square means adjusted R square. Okay. So how you are going to find this? 1 minus 1 minus R square into uh, into n minus 1 upon n minus p minus 1. Okay. So here P is nothing but the probability. P is equal to number of predictors. So it is useful when multiple regression is there. Okay, so penalize unnecessary variables. Okay, so it is useful for multiple regression. Okay, and penalize unnecessary variables. Okay, penalize unnecessary variables. Okay. So next, we will go for the hands-on practice for these things. So for that, I have to open my Jupyter book. So just a second, let me open the Jupyter book. So just hold a second. It take time, I think 1 or 2 seconds. Okay, so it opened. So now I am going to create one new file, or you can say new notebook. So just click on the select. Okay. So now I am going to write the code for this. Okay. So for all the metrics, what we have learned till now, like your MAE, RMSE, R square. So for that, I am going to write the code. Okay. So for that, I have to import some library first. So we will import the pandas for reading the dataset. So import pandas as PD, and then we will import the numpy for the array portion. So import numpy as NP, and then we will import like the linear regression model. Okay. So from sklearn dot linear model, we will import a linear regression. Okay. And the next part is like we will import the mean absolute error MSE and your R square from the sklearn matrix. Okay, so from sklearn dot matrix import mean absolute error, and we will import the mean squared error, and what we will import r r square score, r2 score. Okay, so r square, so r2 score. Okay, so just run this. Oh, there is like sklearn dot matrix no module found. Okay. Oh, sorry, spelling METRI. Sorry, my bad. Oh, sorry, I forgot to import one more module, which is your polynomial features. Okay, so for the polynomial features, we will import like sklearn pre-processing. Okay, so from sklearn dot pre-processing import your polynomial features. Polynomial features. Okay, so now we have imported all the necessary of your libraries. So now I am going to write the data set. Okay, so for that I will use the previous data set for the in we will use for the predicting the house. So same data set I am going to use here also. So data is equal to pd dot data frame. Okay, and here I will give my data. So the first one I will give the size. So size, and it value I will give. So it value is like 2100, comma 1600, comma 2400, comma 1416, 1416, comma 3000, comma your 1980, 1980, and 1534. This is a random data set. You can take whatever in your mind. Okay, 2450. Okay. So here I have given the size, and then one more attribute. I will give like the bedrooms. Okay. So for bedrooms, I will give like the data is something like 3242, 3242, and 4334, 4334. Okay. So 3242, 3242, 4334. Okay, so I have given the size of the bedroom. Now I will give the age. Age means like how old the house is. Okay, so here like I will give the age. So age will be your like 15, 10, 20, 15, comma 10, comma 20, comma your 18, 30, 12, 18, comma 13, comma 12, comma 8, comma 25, 8, comma 25. Okay, so this is your age of your house, and next we will give the price. Okay, so price I will give it like price. So price is nothing but your how much? Oh, sorry. So for the first one, I am going to give like 40,000, 40,000, and then I will give like, or you give the size like 4 lakh. Okay, and next give like 3 lakh 30,000, 3 lakh 30,000, and then next one give like 3 lakh 69,000, 3 lakh 69,000, and then give like 2 lakh 32,000, 2 lakh 32,000, and then next is like 5 lakh 40,000, 5 lakh 40,000, comma your next will be, oh, here give the comma everywhere. Okay, 5 lakh 40,000, and then the next one is like 3 lakh 56,000, 3 lakh 56,000, and then the next is your 2 lakh 98,000, 2 lakh 98,000, and then give the next one is you like 4 lakh 52,000, 4 lakh 52,000. Okay, so I have given the data. So just close the bracket and run this. Okay. So okay, I have given the data for my house price prediction. Okay. So now we'll give like separate the data with in which is like dependent or independent. So X is your independent, X is equal to data, and which is your independent, you will give like size, bedroom, and age. So size, and then your bedrooms, and then your age. Okay, so I will give like the value of bedroom, and then I will give the age. Okay. And now in the y, I will give my the dependent variable, which is like y is equal to data. And in the data, which is my dependent, yeah, you are correct, price. Okay. So price I will give and just run this. So I have given the dependent and independent variable. So now I will go to the write the code for the linear regression. First we will make the regression part, and then we will like the evaluation, and then we will calculate the your MAE, RMSE, and R square. Okay. So now I am going to create the model first. So model is equal to your linear regression, and then we will write like model dot fit, and we have to fit it in the x comma y value. Okay, so x comma y dependent and independent variable we are going to fix. Then we are going to predict the value y underscore predict is equal to model dot predict, and then we will give the value of x, what we are want to predict, the x value. Okay, so just run this. Now I'm going to evaluate it. Okay, so we will write like for the MAE, RMSE, and R square. So evaluation, let me write down the evaluation part. Evaluation. Okay, so we will do the evaluation. So first I will write like MAE is equal to mean absolute error, and we will find like in the y and y predict. Okay, and next we will find like RMSE is equal to np dot square root of which you are going to find your mean squared error, and you will find like for the same y and y predict. Okay, so y comma y underscore predict. Okay, and next you are finding the R2 value, r square is equal to r square underscore score, and you will give the value. Okay, so y comma y predict. Okay, so just run this. So we have did the evaluation. So now I'm going to print the value. Okay, so for printing the value, nothing, I have to write like the print statement, print, and give the value what you want to predict. So MA and its value. So MA. Okay, so like that I will give. So print RMSE, print RMSE, and the value is RMSE. Okay, and next we will print your R2 value now. So R square, and the value is like R2. Okay, so just run this. So here it gives the value for MAE, R square, and RMSE. Okay, so it applies this formula which I have told you here. So for the MAE, it applied this formula, and for RMSE, it applied this formula, and for the R square, this it applied this formula and give the value. Okay, so I told you like R square value is range between 0 to 1. So just see it here. So its value is like 0 to 1 only. So 0.91. Okay, so 0.91 means it is like you can say the better model. Okay, so this is how we are finding the value of the different metrics. So now we will do it for the polynomial regression. Okay. So for the polynomial regression, we will use the degree 3, sorry, 2 or 3, whatever you can do. Okay, so for now, for just the demo, I am going to write for the degree 2. Okay, so for that, we have to write like poly is equal to polynomial features and degree is equal to 2. Okay, and then we will write like x underscore poly is equal to poly dot transform fit transform, and then we are going to value of x. We will pass the value of x here. So now what we will do? So we will do the polynomial regression model. Okay. So for that I will write like poly underscore model is equal to linear regression. Okay. And then we will fit it with the x polynomial and your y value. Okay. So poly underscore model dot fit, and we will fit it into the x poly comma y, x underscore poly comma y. Okay, and then we will going to predict the polynomial value. Okay, so for that we will write like y underscore predict, okay, underscore poly is equal to poly model predict, poly model dot predict, and it will predict the value of x poly. Okay, so just run this. So here what we have did. So we have initialized the polynomial regression model with the degree 2, and we have like create a model, and then we have fit it, and then we are predicting the value from that. Okay, so now we will do like calculate the MAE and RMSE and R square of the polynomial regression. Okay, so for the polynomial regression, I have to write like the MAE underscore poly is equal to mean absolute error, and then we will pass the value of y comma y underscore predict underscore poly. Okay, so let me copy this because I have need in the next two also the same thing. So RMSE underscore poly is equal to your np dot square root np dot square root, and we'll give like the mean squared error. So mean squared error, and then we will give the value of this y comma y predict poly. Okay. So now for the r square, so r square underscore poly is equal to, you have to write like the r2 score, r2 score, and you have to pass the value. Okay. So just run this. So now we are going to print the value. Okay. So the print, we will write like the print, and your polynomial regression, we are using the regression, polynomial regression, and the value of MAE is how much? Poly underscore, sorry, MAE underscore poly. Okay. So now the same thing we will write like for the RMSE also. So here only we can print like comma, and then we will print like this one for RMSE is your nothing but comma, and RMSE poly comma, and you can write like for the R square comma R2 poly. Okay, so just run this. So here you can see like the polynomial regression for MAE is your 4 point itna, and polynomial regression for RMSE is itna, and regression is your 1. Okay, so here the R value in the regression model, it was coming like your 0.91, and in the polynomial regression it came like 1. Okay, now we'll like did we can see the difference between using the linear regression and your polynomial regression, and using that both different algorithm, we are getting the different output. Okay, so in the polynomial, the R2 value is 1, which is our better model to predict the outcomes with respect to the linear regression. Here, if we will apply the linear, then and if we apply the polynomial, so polynomial gives the better result. Okay, so this is about the comparison of the two model till now, which we have did. So we have seen like lower MAE or RMSE is equal to better performance, and higher R square means better fit. Okay, but too high R square is close to 1 on the training data may lead the overfitting. Okay, so the common pitfalls is like overfitting is too complex, and like high degree polynomial. So here we have seen like the for the high degree polynomial, it comes like 1. Okay, so it is the maximum. Okay, 1 is the maximum. It cannot go behind the 1. Okay, and next one, under fitting, we have seen like too simple, like linear when data is non-linear. Okay, and multi-collinearity, we have seen like the feature is highly correlated and unsettled coefficient. Okay, and we have seen about the data scaling may be required when features differs a lot in magnitude. Okay, so this is about the regression in the machine learning. So we have learned how to evaluate the regression model using MAE like MAE, RMSE, R square, and adjusted R square, and we have already implemented evaluation in Python on multiple and polynomial regression, and we have compared the model and discussed the pitfalls. Okay, so in the last, I want to do the quick recap like what we have did in this topic is like regression is the fundamental of machine learning. The next step is if continuity of this series. So I will come with the next topic in the next video. So तब तक के लिए if you have understand this all concept in very detailed manner and you have like practice this all things with the hands-on, then just do like our video and just share it with your friend so that your friend can get benefited using this. So तब तक के लिए keep learning and keep exploring. See you in the next lecture. Bye bye.